Homework 29 leaves off where homework 28 was doing, where we're finding the solutions. This again is going to be in our interval between 0 and 2 pi. This one happens to be when we have our squared terms. So again, you are going to want to have that table handy that has all of your angles for reference so that you can go back and check and see where your tangent is equal to some value or whatever it may be. So you want to have that table handy on homework 28 and on homework 29. So again, we're going to solve these, and so I'm going to have 3 tangent squared of x equals 1. I'm going to divide by 3, so tangent squared of x equals 1/3. And so since I have tangent squared, in order to solve that, I have to take the square root. And when I do the square root, I do plus or minus. So the tangent of x is going to equal plus or minus the square root of 1/3. Of course, I want to rationalize that. And so I'm going to multiply by the 3. And so I'm going to have plus or minus square root of 3 over 9, the square root of 9, which is 3. I should probably write that up. 3/9. And so I have the square root of 3 over the square root of 9, which is just a plain old 3. So I'm going to look up and I'm going to find all the ones with positive square root of 3 over 3 and all the ones with negative square root of 3 over 3. So I'm going to end up having 4 answers most likely. So again, I'm just going to go back to my handy dandy table. Which I left in my other packet of notes. So if I grab my handy dandy table from my other packet of notes, now I've got my handy dandy table. So under my tangent column, square root of 3 over 3 is at pi over 6. If I keep going down, negative square root of negative square root of 3 over 3 is at 5 pi over 6. If I keep going down, I keep moving to cosine instead of tangent, positive square root of 3 over 3 is at 7 pi over 6. And if I keep going down, I have a negative square root of 3 over 3 at 11 pi over 6. So again, I should have 4 answers, 2 that were at square root of 3 over 3, and 2 that are at negative square root of 3 over 3. You don't have to have these in order. If you have them in a different order, that's fine. Number 2, we are doing cosecant squared of x, same thing. First of all, adding my 4. So 3 cosecant squared of x equals 4. I'm going to divide by my 3. So cosecant squared of x equals 4/3. I then have to do the square root. And if I rationalize that, the cosecant of x, I still can't write, cosecant of x is going to equal. Now when I simplify this, the square root of 4 is 2, so I'm going to get 2 square root of 3 on top. On the bottom we have the square root of 9, which is 3. And of course, since we did the square root, we have to do plus or minus. So we're going to look up plus or minus 2 square root of 3 over 3. Under my cosecant column, so 2 square root of 3 over 3 is at pi over 3. Under my cosecant column, I also have 2 pi over 3. Then I have a negative 2 square root of 3 over 3 at 4 pi over 3. And if I look under my cosecant column, negative 2 square root of 3 over 3 is at 5 pi over 3. So I have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3 for my 4 answers. Number 3 then, solving that one, of course we're going to add our 1. 2 cosine squared of x equals 1. So cosine squared of x would equal 1/2. Doing my square root. multiplying by the 2, I'm going to get the cosine of x equals plus or minus. On the top, I'm going to have square root of 2. On the bottom, I'd have square root of 4, which is just 2. So I'm going to look up plus or minus square root of 2 over 2. So underneath the cosine column, cosine square root of 2 over 2 is at pi over 4. Then I have a negative square root of 2 over 2 at 3 pi over 4. Then I have negative square root of 2 over 2 at 5 pi over 4. And then in quadrant 4, I have square root of 2 over 2 at 7 pi over 4. So I have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So just solving those and remembering when I do the square root, I have plus or minus my answer. So I end up with 4 answers usually, 2 for each of them. For 5 and 6, we are finding solutions in an interval for a trigonometric equation with a squared function again, but this time we want to think about it in the form of a quadratic equation. So if I take out the word cosines, I would have x squared minus 2x minus 3. And I want to think about how I would factor that. So if I'm going to factor that, I would have x and x. Since the end is negative, a plus and a minus. Factors of 3, I'd have to have a minus 3 and a plus 1 to get the minus 2 in the middle. I'm going to replace my x's with cosine of x. So the cosine of x plus 1 times the cosine of x minus 3 equals 0, and I now have it in factored form. So now I'm going to solve these like I did the ones in factored form. I'm basically going to split them into 2 different problems. So either my cosine of x is going to equal negative 1, or my cosine of x would equal positive 3. So I'm then going to just grab my table and look. Under my cosine, where does it equal negative 1? At pi, if I look, that's the only place I see a negative 1. Where does my cosine equal 3? If I look down my list, there is nowhere that it equals 3. And so on this one, the only answer I'm going to have is just pi. So number 5, again, if I look at this one, I'm looking for tangent. But if I think about it without the word tangent, I would say x squared minus x equals 0. If I'm going to factor that, I'm going to factor out one of my x's and take out the greatest common factor. So I'd have x times x minus 1 equals 0, right? If I take an x out of here, I have an x left. X out of there, I have minus 1. So replacing my x's with the word tangent, I would have the tangent of x times tangent of x minus 1 equals 0. So if I took this times this, I get this. This times that, I get that. And so it checks out that if I multiply it out, it's what I originally started with. Excuse me. So breaking this down into my 2 problems, either the tangent of x equals 0 or the tangent of x equals, or tangent of x, trying to skip a step, minus 1 equals 0, so the tangent of x equals 1. So I'm going to look for all my values where either the tangent of x equals 0 or 1. Looking under my tangent column, I equal 0 at 0 and at pi. Again, it's under the 2 pi, but we're not including the 2 pi in our answer because we have the parenthesis there, not the bracket. And where does the tangent equal 1? Pi over 4 and 5 pi over 4. So nothing repeats there. We have 0, pi, pi over 4, and 5 pi over 4. And all 4 of those would go in for our answer then. Number 6. Again, if we think about this one, we would have 4x squared plus 4x plus 1 equals 0, taking out the word sign. And so if I'm going to factor that, 4x squared, I'm going to try 2x and 2x. My signs are both pluses. And if I do 1, I get 2x plus 2x, which is the 4x in the middle. So that factors out. So I would say that I have 2 sine of x plus 1 times 2 sine of x plus 1 equals 0. And again, I could FOIL that out just to double check it, but that should be good. In this case, both of my factors are the same, so it's going to give me the same value. So I'm just going to solve one of them. If 2 sine of x plus 1 equals 0, 2 sine of x would equal -1, so sine of x would equal -1/2. And so I'm going to look at my table for where does the sine of x equals -1/2. And if I look down my list, I am at 7 pi over 6. And I am at 11 pi over 6. So at 7 pi over 6 and 11 pi over 6, my sine of x equals -1/2. 7, 8, and 9 say finding the solutions in an interval for a trigonometric equation using your Pythagorean identities. So you might want to have your Pythagorean identities handy. Sine squared plus cosine squared equals 1. That's the most common one we use. Tangent squared plus 1 is equal to secant squared. Cotangent squared plus 1 equals the cosecant squared. So those identities we're going to use and substitute in order to solve our equation. Normally we want them in terms of sine and cosine. So keep those in mind. So we have negative cosine squared of x minus 1 equals the sine of x. And so if I think about my Pythagorean identity, sine squared of x plus cosine squared of x equals 1. So the cosine squared of x is going to equal 1 minus the sine squared of x. I'm going to substitute that into my equation so that I have it written in terms of just the sine only. So I'm going to have minus 1 minus the sine squared of x minus 1 equals the sine of x. Using my distributive property, -1 plus the sine squared of x minus 1 equals the sine of x. Setting that equal to 0, making sure my squared term is positive, I'm going to move this over here. So I'm going to have sine squared of x minus the sine of x, and then a -1 plus a -1 would be -2 equals 0. I now want to factor that out. So I'm thinking of that as x squared minus x minus 2. X and x plus and a minus, I'd have to have a -2 and a +1. So that would factor into the sine of x plus 1 and the sine of x minus 2 equals my 0, smooshing that in there. So either I'm looking for the sine of x equals -1, because I'd have to move that over, or the sine of x equals, and that would change to a +2. So I'm looking for the values where the sine of x equals -1 or +2. So I'm going to grab my table, which I hid. Sine of x equals -1. Going down my list, there's only one answer, 3 pi over 2. Looking for where the sine of x equals a +2. If I look down my list, there are no 2's in there. None for that one. So I'm only going to have one answer. My only answer is going to be 3 pi over 2. Number 8, same kind of thing. You'll notice I have cosine squared in there. We know that sine squared of x plus cosine squared of x equals 1. so that cosine squared of x equals 1 minus sine squared. And again, I'm going to substitute that in, so I have everything in terms of sine. So I would have 2 times 1 minus the sine squared of x equals 2 plus the sine of x. So 2 minus 2 sine squared of x equals 2 plus the sine of x. So in this case, I'm going to subtract my 2 and add my 2 sine squared of x. So minus the 2 plus the 2 sine squared of x. So 0 is going to equal 2 sine squared of x plus the sine of x. So if I'm going to factor that one, you can see I can factor out the sine of x. If you need to, make it 2x squared plus x, factor it that way, but this one I think we can just see there's a common factor of sine of x. So if I take out the sine of x, I get 2 sine of x plus 1. So either the sine of x is going to equal 0, or 2 sine of x is going to equal minus 1. So sine of x equals minus 1/2. So sine of x equals 0 or negative 1, excuse me, negative 1/2. And then I'm going to look those up on my table. So sine of x equals 0 at 0 and at pi. Again, it's also at 2 pi, but we're not including 2 pi in our answer. So sine of x equals negative 1/2 at 7 pi over 6. And negative 1/2 at 11 pi over 6. So all 4 of those are going to go in for our answer. 0 pi, 7 pi over 6, and 11 pi over 6. Number 9. This time I have a sine squared. So again, thinking about solving sine squared plus cosine squared equals 1, the sine squared would equal 1 minus the cosine squared of x. And so I'm going to have negative 5 cosine of x equals negative 2 times 1 minus the cosine squared of x plus 4. So negative 5 cosine of x equals negative 2 plus, because I have a negative times a negative, 2 cosine squared of x plus 4. Since this is positive, I'm going to move this over here. So I'm going to add my 5 cosine of x. So 0 is going to equal 2 cosine squared of x plus 5 cosine of x. Negative 2 plus 4 would be plus 2. So I'm thinking about factoring 2x squared plus 5x plus 2. 2x and x, a plus and a plus. And I'd have to have the 2 here and the 1 there. 4x plus 1x is 5x in the middle. So this is going to factor into 2 cosine of x plus 1 and cosine of x plus 2. Again, you could FOIL that out just to double check it, but that should be good. So 2 cosine of x would equal minus 1. Cosine of x is going to equal negative 1/2. That's one of them I'm going to look up. And then over here, cosine of x would equal negative 2. So I'm going to look up where the cosine of x equals negative 1/2 and negative 2. So cosine of x equaling negative 1/2 would be at 2 pi over 3. Cosine of x equals negative 1/2 at 4 pi over 3. And if I look for cosine of x equals negative 2, there aren't any that equal negative 2. So I'm just going to have those two answers, 2 pi over 3 and 4 pi over 3. 10, 11, and 12, we are finding solutions in an interval. This time we're using the double angle identities. So you're going to want to find your sheet with your double angle identities. Sine of 2x is 2 sine of x cosine of x. Cosine of 2x, cosine squared minus sine squared, 1 minus 2 sine squared of x, or 2 cosine squared minus 1. Again, you're going to have to pick out which one you think is the most appropriate. If it doesn't work, try one of the other ones until you find one that works. And then, of course, we have the double angle for the tangent of 2x is 2 tangent of x over 1 minus tangent squared of x. Most of the time, they're just going to stick with sine and cosine. So you'll want to keep those handy. So this one starts off with the cosine of 2x. Because this is in terms of sine, I want to use the double angle one for cosine of 2x. That just has the sine in it. That way I don't have more than one in there. So I have 1 minus 2 sine squared of x for one of my double angles for cosine of 2x. So that's the one I'm going to use to substitute in for my cosine of 2x. So I'm going to have negative sine of x plus 1 minus 2 sine squared of x equals 1. I'm then going to subtract my 1 so I can set it equal to 0. So I have negative 2 sine squared of x minus the sine of x equals 0. I don't like my sine squared to be negative, so if I switch it around, 0 equals 2 sine squared of x plus the sine of x, or just divide by negative 1. That'll switch your signs. I never like my squared term to be negative. It's hard to factor that way. This one you can see we have a greatest common factor. So we can take out the sine of x. We take out 1 sine of x, we would get 2 sine of x plus 1. And so now we should have that factored out. So again, we're just looking for the interval between 0 and 2 pi. Either the sine of x is going to equal 0, or if I solve this one, 2 sine of x equals a minus 1, so sine of x equals negative 1/2. So I'm looking for the values where we have 0 or negative 1/2. Back in my table, again, same table we've been using all along, looking up our values. I forgot to bring that up in the things that you want to have handy, but you want to have that table handy. So sine of x equals 0 at 0. At pi, again, it's also at 2 pi, but we're not including 2 pi in our answer. Sine equals negative 1/2 at 7 pi over 6. And negative 1/2 at 11 pi over 6. And so we're going to have those 4 answers: 0 pi, 7 pi over 6, and 11 pi over 6. Number 11. This time our double angle is the sine of 2x. The sine of 2x is 2 sine of x cosine of x, if you look at your double angle formulas. And so that's what we're going to substitute in there for the sine of 2x. So we have 2 sine of x plus 2 sine of x cosine of x equals 0. And you can see on this one, we're going to be able to factor out the 2 sine of x. So 2 sine of x times 1 plus the cosine of x equals 0. And we have that all factored out. So if 2 sine of x equals 0 and I divide by 2, that just gives us the sine of x equals 0. On the other one, cosine of x, if I move my 1 to the other side, it's going to be a negative 1. So we're going to look for where the sine of x equals 0 or the cosine of x equals negative 1. So looking at my table, for the sine of x equals 0, we were at 0 and pi. We just did that on another problem. Again, 2 pi's on our list, but we're not including the 2 pi. Where we look for the cosine at negative 1 is at pi, and that's the only spot. But since we already have pi on our list, we don't need to add it to our list. So we're just going to say 0 and pi are our only answers on that one. So this one gave me the answer of 0 and pi. This one gives me the answer of pi, but we don't need to put it in there twice. So just 0 and pi for our solutions. Number 12, again we have the sine of 2x. The sine of 2x is equal to 2 sine of x cosine of x. That's our double angle identity that we're going to want to use on that one. So we're going to have negative 2 sine of x cosine of x, since there was a negative in front of our double angle, plus 2 cosine of x equals 0. So on this one we can factor out the 2 cosine of x. If we take that out, that's going to leave us negative sine of x plus 1 equals 0. So 2 cosine of x equals 0. If I divide by 2, cosine of x would equal 0. Negative sine of x would equal negative 1. If I divide, sine of x would equal positive 1 then. So I am looking for where is the cosine of x equals 0 and where is the sine of x equal 1. Cosine of x equals 0 at, whoops, not at 0. I'm trying to write the 0 I looked up. Cosine of x equals 0 at pi over 2. Cosine of x equals 0 at 3 pi over 2. Sine of x equals 1. Sine of x equals 1 at pi over 2. Sine of x equals 1 nowhere else. Just at the pi over 2. And so again, when I look at this answer, since I already have the pi over 2, I'm just going to put in pi over 2 and 3 pi over 2, since this is already part of that answer. (13, 14, and 15), we are solving a trigonometric equation modeling a real-world situation. And it says, suppose the height of the ground of a person sitting on a Ferris wheel is described by the following. H of t equals 18 minus 15.9 times the cosine of 2 pi over 5t. In this equation, h of t is the height above ground in meters, t is the time in minutes. The ride begins at t equals 0 minutes. So during the first 5 minutes of the ride, when will a person be 24 meters above the ground? So we're going to put 24 in here for h of t. Now we are going to use our calculator in order to evaluate these. Again, since this is in terms of pi, I know I'm in radian measure, so I need to make sure my calculator is also in radian measure. Somehow I got tilted a little crooked. Let me straighten that out. I wonder how long that's been like that. You guys will know. And so on my calculator, again, if you have the Casio, you're going to hit mode, and hit 2 so that you're in radians instead of degrees. Mode 2 puts you in radians. So my equation says 24 equals 18 minus 15.9 times the cosine of 2 pi over 5t. I'm going to rearrange this and solve this for the cosine. So I'm going to subtract my 18 first. So 24 minus 18 is going to give me 6. Then I'm going to divide by my negative 15.9. Now, what I'm going to do, first of all, is I'm going to figure out where my angle is. But I want my angle to be positive, and then I'm going to figure out what quadrants I'm in for cosine to be negative. So when I do this on my calculator, I'm going to do the cosine of 6 over 15.9. Notice I'm using the positive and not the negative. That's going to tell me my angle in quadrant 1. So I'm going to do, I better do inverse cosine. Inverse cosine. So shift cosine, inverse cosine, in parentheses, I'm going to do 6 fraction 15.9. I could use 6 divided by 15.9. And if I hit equal, it tells me that I am at 1.18. I'm rounding that off to the nearest hundredth, by the way. So it's really 1.183, but I rounded that off. Now this is in quadrant 1. I know that cosine is negative when the x value goes backwards, so I need to be in quadrant 2 or in quadrant 3. So I really need to take 3.14 minus 1.18 to be in quadrant 2, and 3.14 plus 1.18 to be in quadrant 3. So if I go ahead and do that, 3.14 minus 1.18 would give me 1.96, and 3.14 plus 1.18 gives me 4.32. Now, that is really equal to this. So, 2 pi over 5t either equals 1.96 or 2 pi over 5t equals my 4.32. I have to solve each of those for t. So if I'm going to solve for t, I'm going to multiply by 5 over 2 pi. Same thing down here, 5 over 2 pi. Now, I just use the pi button on my calculator instead of putting in 3.14. If you do the 3.14, make sure you multiply by the 2 first before you try to do your dividing. That's why I use the 2 pi. So on my calculator, I'm going to put in 1.96 times 5 divided by 2 shift and the EXP key, which puts the 2 pi on my calculator. So 1.96 times 5 divided by 2 pi gives me 1.559, so 1.56 when I round that off to the nearest hundredth. Doing my other one, 4.32 times 5 divided by 2 shift EXP to put the pi on there. So 4.32 times 5 divided by 2 pi is 3.4, and I've got to round that off to 4 because there's a 7 behind my 3, 3.437, so 3.44. Those are going to be my 2 answers, either at 1.56 minutes or 3.44 minutes is when your person's going to be 24 meters above the ground. Key to this problem, whether this is positive or negative, we're going to put it in as a positive, find your answer in quadrant 1, and then change it to whatever quadrants you need to be in, whether it's 2 and 3 or 1 and 4 or whatever it might be, then do your conversion. Now on Alex, they're going to do it all at once. It's going to be a great big long problem. I found that it's probably simpler just to do it step by step by step, and hopefully you come up with your right numbers on your calculator. Again, make sure you're in radian mode on your calculator. So number 14, if we look at number 14, it says for a fixed location, the number of sunlight hours in a day fluctuates throughout the year. Suppose the number of daily sunlight hours in a particular location can be modeled by the following. L of t equals 12 plus 2.9 sine of 2 pi over 365t. In this equation, L of t is the number of sunlight hours in a day. T is the number of days after March 20th. So T0 means March 20th, T1 is March 21st, T2 is March 22nd, and so far. Suppose we start at T0, which is March 20th. During the first 365 days, when will there be 14 hours of sunlight? So again, we're just going to put the 14 in here. The 2 is already in there from their calculation. So do not round your answer to the nearest hundredth. And so in this case, 14 equals 12 plus 2.9 sine of 2 pi over 365t. I'm going to subtract my 12, which gives me 2, and then I have to divide by the 2.9. So this is positive, which is good. I'm going to use the sign or inverse sign of 2 over 2.9. That's going to give me my answer in quadrant 1. Sign is positive in quadrant 1 and in quadrant 2. So, first of all, figuring out our inverse sign. Again, we're in radian mode. Shift sign of parentheses 2 divided by 2.9 or 2 fraction 2.9 gives us, rounding off to the nearest hundredth, 0.76. That one's in quadrant 1. We don't have to do anything to move that one, but we also need to find quadrant 2. So if you think about quadrant 2, I'm going to subtract from 180. So I'm going to take 3.14 minus my 0.76. So 3.14 minus 0.76 gives me 2.38. Now I'm going to take each of those values, set it equal to my 2 pi over 365t. So 2 pi over 365t either equals 0.76 or 2 pi over 365t equals 2.38. If I'm going to solve that for t, I have to multiply by the reciprocal, so I'm going to multiply by 365 over 2 pi. Again, I'm going to use the pi button on my calculator just because it's a little more accurate. So I'm going to start off 0.76 times 365 divided by 2 shift pi. So the 2 pi is all together. Otherwise, you'd have to use parentheses around your 2 times 3.14. Pi button is much easier to do. My first answer, 44 point, rounding to the nearest hundredth, 15, because I have 149. So I have to, oops. Oh, I'm rounding off not to the nearest hundredth. I'm not rounding where I'm supposed to. Round to the nearest day. That's why my answer doesn't look right. Rounding off to the nearest whole number then. Excuse me, my first answer then would be 44 days. My second one, I'm going to take 2.38 times 365 divided by shift, nope, not shift yet, divided by 2 shift exp. So I have 2.38 times 365 divided by 2 pi. If I hit equals, I get 138.26, but rounding that off to the nearest day, 138 days then. So either at 44 days or 138 days is where I'm going to have 14 hours of sunlight. And one more of those, number 15. The population sizes of many animal species rise and fall over time. Suppose that the population size of a certain species can be modeled by the following. P of t equals 4,079 minus 1,207 times the cosine of 2 pi over 5t. In this equation, P of t represents the total population size. T is the time in years. Suppose we start at t equals 0 years. During the first 5 years, when will the population size be 4,800? So 4,800 equals 4,079 minus 1,207 cosine of 2 pi over 5t. So we would subtract our 4,079. 4,800 minus 4,079 is 721. Again, we end up dividing So we're going to divide by the negative 1207 to equal our cosine of 2 pi over 5t. Again, when we do this, we want to figure out quadrant 1, so we're not going to use the negative. We're going to do the inverse cosine of the positive, 721 over 1,207, figure out what angle is in quadrant 1, then we'll change it to the quadrants that we need to use. So, in radian mode, shift cosine, parentheses, 721 divided by 1,207 gives me 0.93. That's in quadrant 1. We want our cosine to be negative, so our cosine is going to be negative in quadrant 2 or quadrant 3. So in quadrant 2, we are going to take pi minus our value. So 3.14 minus 0.93. In quadrant 3, we're going to take pi plus our angle. So 3.14 minus 0.93 gives me 2.21. 3.14 plus 0.93 gives me 4.07. So, we are going to say that 2 pi over 5t either equals 2.21 if we're in quadrant 2, or 2 pi over 5t equals 4.07 if we're in quadrant 3. Again, to solve that, we have to multiply by the reciprocal, so 5 over 2 pi. So, on my calculator, 2.21 times 5 divided by shift exp, whoops, I forgot the 2, divided by 2 shift exp. So 2.21 times 5 divided by 2 pi gives me, what am I rounding to? Round your answer to the nearest hundredth. So I have 1.758. So I would have to round that off to 1.76. 1.758 rounds off to 1.76. Then I'm going to do 4.07 times 5 divided by 2 shift exp. So 4.07 times 5 divided by 2 pi gives me 3.238, so 3.24. So at 1.76 years or 3.24 years, the population is going to be 4,800.